Table of Contents. Introduction. The Data Storyteller's Toolkit. Started at 0 hours, 0 minutes, and 0 seconds. Chapter 1. Sourcing your raw materials. Started at 0 hours, 10 minutes, and 37 seconds. Chapter 2. The Cleanup, Transforming Messy Data into Usable Assets. Started at 0 hours, 21 minutes, and 49 seconds. Chapter 3. The Blueprint, Building a Relational Data Model. Started at 0 hours, 34 minutes, and 7 seconds. Chapter 4. Speaking the Language, Introduction to DAX. Started at 0 hours, 43 minutes, and 45 seconds. Chapter 5. Leveling Up, Intermediate DAX and Time Intelligence. Started at 0 hours, 55 minutes, and 31 seconds. Chapter 6. Visualizing the Story, Choosing the Right Charts. Started at 1 hour, 6 minutes, and 8 seconds. Chapter 7. Design for Impact, Formatting and User Experience. Started at 1 hour, 19 minutes, and 4 seconds. Chapter 8. The Final Polish, Publishing and Sharing. Started at 1 hour, 30 minutes, and 1 second. Conclusion. Your journey as a data analyst. Started at 1 hour, 41 minutes, and 47 seconds. Introduction, the Data Storyteller's Toolkit. Sections. Section 0.1, Why Power BI? Moving beyond the limits of spreadsheets. Section 0.2, The 3 Pillars of Power BI, Desktop, Service, and Mobile. Section 0.3, Setting up your environment, Installation and Account Basics. Section 0.4, Navigating the Canvas, a tour of the interface and workflow. Data is useless if it sits silently in a database. For years, we have treated data analysis as a mathematical exercise, a cold process of calculating sums and averages. But numbers alone rarely change minds or drive strategy. To make an impact, you must translate those numbers into a narrative that human beings can understand and act upon. Welcome to the world of Power BI. You are no longer just an analyst, you are a data storyteller. This book is your manual for that transformation. We aren't just learning software features, we are learning how to build a bridge between raw information and business wisdom. Whether you are migrating from Excel or starting your analytics journey from scratch, the toolkit you are about to unlock is powerful, flexible, and surprisingly accessible. Let's open the box. Figure, a conceptual illustration showing a metamorphosis of data. On the left, a chaotic pile of binary code and jagged line graphs in grayscale. In the center, a glowing stylized funnel labeled Power BI. On the right, vibrant, clear geometric shapes, bar charts, and maps emerging, forming a cohesive dashboard that looks like a city skyline. High contrast, modern tech aesthetic, blue and gold color palette. 0.1 Why Power BI? Moving beyond the limits of spreadsheets. If you are reading this, you likely have a relationship with Microsoft Excel. It's probably a love-hate relationship. Excel is the Swiss Army knife of business, it is indispensable for quick calculations and ad hoc lists. However, when you try to build a house with a Swiss Army knife, you run into trouble. Spreadsheets were designed for individual cell manipulation, not enterprise-scale intelligence. You have likely faced Excel fatigue, the dread of opening a file that takes 5 minutes to load, the fragility of VLOOKUPs that break when a column moves, or the nightmare of emailing report_final_v3_real_final.xlsx to a team of 10 people. Power BI changes the fundamental rules of engagement. It is not a spreadsheet, it is a database engine attached to a visualization canvas. Scalability and automation. In Excel, 1 million rows is a hard limit. In Power BI, millions of rows are a warm-up. Because Power BI compresses data significantly, you can analyze massive datasets on a standard laptop without the system grinding to a halt. More importantly, Power BI separates data storage from data reporting. When you build a report in Power BI, you are building a reusable pipeline. You define the cleaning steps once. Next month, when new data arrives, you simply click refresh. The software reruns your logic, cleans the new data, and updates every chart automatically. No more copy-pasting. Interactivity versus static reporting. Excel charts are typically static images. If a manager asks, "What drove sales in the East region?" you usually have to go back to the data, filter it, create a new chart, and paste it into a slide. In Power BI, everything is connected. Clicking on the least bar in a chart instantly filters every other visual on the page to show only data for the East. This allows users to answer their own questions by exploring the data, rather than waiting for you to generate a new report. Figure, a split-screen comparison infographic. Left side labeled traditional spreadsheet showing a user looking stressed at a grid of numbers with a broken formula error pop-up. Right side labeled Power BI experience showing a user clicking a slice of a donut chart, with arrows indicating that surrounding bar charts and maps are dynamically updating to match the selection. Clean, flat vector style. 0.2 The 3 pillars of Power BI: desktop, service, and mobile. To understand how Power BI works, you have to stop thinking of it as a single application. It is an ecosystem consisting of 3 distinct parts. I like to think of this workflow as the author, the publisher, and the reader. Power BI Desktop, the author. This is your workshop. Power BI Desktop is a free application you install on your computer. This is where 90% of the magic happens. Here, you connect to data, write formulas, DAX, design your data model, and arrange your visuals on the canvas. If you are the analyst, you will live here. It is a sandbox where you can experiment without breaking anything. Power BI Service, the publisher. Once your report is a masterpiece, you publish it to the cloud. The Power BI Service, app.powerbi.com, is the online portal where collaboration happens. It is a SaaS, software as a service, platform. Think of the service as an art gallery. You don't paint the picture here, you display it. In the service, you manage who can see the report, set up automatic data refreshes, and create dashboards, a specific term in Power BI we will cover later. This is where your manager and stakeholders access your insights. Power BI Mobile, the reader. Executives are rarely sitting at desks, they are in meetings or airports. The Power BI mobile app allows them to consume your reports on phones and tablets. The beauty of Power BI is that you can design a mobile layout view in the desktop version. This ensures that when the CEO pulls up your sales report on an iPhone, it doesn't look like a squashed website, it looks like a native app designed for their screen. Figure, a triangular flow diagram on a white background. Top point is a computer monitor icon labeled Desktop, Build and Author. Bottom right point is a cloud icon labeled Service, Share and Collaborate. Bottom left point is a smartphone icon labeled Mobile, Consume and Monitor. Arrows flow clockwise connecting them. The arrows are gradient orange to yellow representing the flow of data. 0.3 Setting up your environment, installation and account basics. Let's get your hands dirty. We need to install the desktop application. While you can download an executable file from the web, I strongly recommend a different route for Windows users. The Microsoft Store method. Open the Microsoft Store on your Windows PC and search for Power BI Desktop. Install it from there. Why this method? Power BI is updated monthly. If you use the standard installer, you have to manually download the new version every single month. The Microsoft Store version updates automatically in the background, ensuring you always have the latest features without the administrative headache. Account requirements. To use Power BI Desktop, you do not technically need to sign in. You can build reports, save them locally as .pbix files, and be happy. However, to share them, you need an account. To use the Power BI service, you generally need a work or school email address, e.g., name@company.com. Microsoft restricts the use of personal emails, like at gmail.com or at outlook.com, for creating standard Power BI business accounts. If you are learning on your own, you may need to sign up for a Microsoft 365 developer account, which provides a sandbox environment for learning. 0 point for navigating the canvas, a tour of the interface and workflow. When you first launch Power BI Desktop and close the splash screen, the interface might look intimidating. It resembles Excel, but the buttons are different, and there are blank panes everywhere. Don't panic. The interface is divided into 3 specific views located on the left-hand sidebar. The View Selector. Report View, the icon looks like a little bar chart. This is your canvas. It is where you drag and drop visuals and design what the user sees. Table View, the icon looks like a grid. This allows you to see the raw data you have imported. You can't edit cells here, remember, this isn't Excel, but you can audit the data to ensure it looks correct. Model View, the icon looks like an org chart or a diagram. This is the engine room. Here, you connect different tables together, e.g., connecting a sales table to a customers table. The standard workflow. Your journey in Power BI will almost always follow a specific life cycle, often represented by the flow of the interface from left to right on the top ribbon. Get data, connect to your source, Excel, SQL, web, etc. Transform, use the Power Query Editor to clean the mess, removing rows, splitting columns, and fixing formats. Model, define how your data tables relate to one another. Visualize, drag fields onto the canvas to create charts. Publish, send it to the cloud. As we move to the next chapter, we are going to tackle the first and most critical step, getting data. We will leave the theoretical behind and start building our first real connection. Open your laptop. It's time to build.
Chapter 1. Sourcing your raw materials. Sections. Section 1.1. The Art of Connection, Importing Data from Excel, CSV, and Web Sources. Section 1.2. Navigating the Power Query Editor without fear. Section 1.3. Profiling your data, spotting errors and anomalies early. Section 1.4. Applied steps, tracking, editing, and reversing your actions. In the introduction, we established that you are a data storyteller. But every great story needs characters, settings, and a plot. In the world of data analytics, these elements are your raw data tables. Without high-quality ingredients, even the best chef cannot produce a Michelin-star meal. Similarly, without clean, well-sourced data, your dashboards will fail to inform or inspire. This chapter is about gathering those ingredients. We are moving beyond simply opening a file. In Power BI, we establish a live connection to your data. This distinction is crucial. When you connect to data, you are building a pipeline. If the source data changes next week, your report updates with a simple click of a button. We will start by importing data from common sources, then step into the Power Query Editor, the engine room of Power BI, to inspect and prepare that data for the spotlight. 1.1 The Art of Connection, Importing Data from Excel, CSV, and Web Sources. If you are coming from an Excel background, your muscle memory tells you to double-click a file to open it. Power BI works differently. We do not open files, we get data. This mindset shift is the first step toward automation. The Get Data experience is designed to be a central hub for all your inputs. Whether your data lives in a simple spreadsheet on your desktop or a complex table on a public website, the process remains remarkably consistent. Connecting to Excel and CSV. Let's start with the most common scenario, an Excel workbook. Open Power BI Desktop. On the Home ribbon, click on Get Data. Select Excel Workbook. Navigate to your file path and select your file. When you do this, the Navigator window appears. This is your first look inside the file before you commit to importing it. You will see a list of sheets and tables on the left. Figure, high-resolution, photorealistic screenshot of the Power BI desktop navigator window. The window is floating over a blurred Power BI interface. On the left side, a file tree shows sales_data_2024 XLSX expanded to reveal sheet 1 and table_sales. Table_sales is highlighted. On the right side, a data preview grid shows columns for date, product, region, and revenue. Soft, professional studio lighting focuses on the load and transform data buttons at the bottom right, with transform data circled in a vibrant, encouraging orange highlight. Author's note: you will see two buttons at the bottom, load and transform data. As a beginner, you might be tempted to hit load. Resist that urge. Always click transform data. This takes you to the kitchen, Power Query, to inspect your ingredients before serving them. Connecting to a CSV, comma-separated values, file is nearly identical, but simpler. CSVs don't have multiple sheets, so Power BI will immediately show you the preview. It is usually smart enough to detect headers and delimiters automatically. Scraping data from the web. This is where Power BI feels like magic to new users. You can treat a website URL just like an Excel file. Imagine you need a list of US states and their abbreviations to match against your sales data. Instead of typing them out manually, find a Wikipedia page or website with the table you need. Copy the URL. In Power BI, select Get Data Web. Paste the URL into the dialog box and click OK. Power BI scans the HTML of that page, finds anything that looks like a table, and presents it to you in the navigator list. You can simply check the box next to the table you want and bring it into your model. No coding required. 1.2 Navigating the Power Query Editor without fear. When you click Transform Data, a new window opens. This is the Power Query Editor. For many new analysts, this window can feel intimidating. It looks like Excel, but you can't click into a cell and type over the data. This is by design. Power Query is not a spreadsheet, it is a data transformation tool. You are building a set of instructions that Power BI will run every time you refresh your data. Think of Power Query as a recording studio. You are recording a script of actions. Figure, a clean, schematic diagram of the Power Query Editor interface. The image is divided into 4 distinct zones with semi-transparent colored overlays. Zone 1, top the ribbon, labeled the toolbox. Zone 2, left the queries pane, labeled the bucket list. Zone 3, center the data preview, labeled the stage. Zone 4, right query settings and applied steps, labeled the script. The style is modern technical illustration, using Power BI brand colors, yellow-gold accents, on a white background. The 4 key zones. The ribbon, top. This contains your transformation tools. You can split columns, change data types, and filter rows here. The queries pane, left. This lists every table, query, you have connected to. You can rename them here, and you should. Table 1 helps no one. Name it sales_fact or customer_lookup. The data preview, center. This is a sample of your data. It allows you to see the results of your changes in real time. Query settings, right. This is the most important panel. It houses the applied steps, which we will discuss shortly. Do not be afraid to click buttons here. Power Query is non-destructive. You are not changing the original Excel file or the website, you are only changing how Power BI reads that data. Your source remains untouched. 1.3 Profiling your data, spotting errors and anomalies early. Before we start cleaning, we need to know how dirty the data is. In Excel, you might scroll through thousands of rows looking for a blank cell or a typo. In Power BI, we use data profiling. Data profiling gives you an X-ray view of your column quality. To turn this on, 1. Go to the View tab in the Power Query ribbon. 2. Check the boxes for column quality, column distribution, and column profile. Suddenly, a small bar appears under every column header. Green, valid data. Red, errors, e.g., text found in a number column. Dark gray, empty cells. Figure, close-up macro shot of a Power Query column header labeled order_quantity. Below the header, the column quality bar is visible. It shows a horizontal bar graph, 95% green, valid, 2% red, error, 3% black, empty. A tooltip is hovering over the red section, displaying error, data format error. The background is slightly out of focus to emphasize the metrics. The lighting is crisp and clinical, emphasizing precision. This feature is a lifesaver. If you see a red bar in your revenue column, you know immediately that someone likely typed not applicable or TBD into a currency field in the source file. You can fix these issues before they break your formulas. By right-clicking the column header, you can choose Remove Errors or Replace Errors, ensuring your analysis is built on a solid foundation. 1.4 Applied Steps: Tracking, Editing, and Reversing your actions. If there is one feature that will make you fall in love with Power Query, it is the Applied Steps window located in the right-hand panel. In Excel, you have Undo, Ctrl+Z. But if you save and close the file, your undo history is gone. In Power Query, every single click you make is recorded as a step in a sequence. This sequence is saved with the file forever. How it works. When you import data, Power BI automatically creates steps like source and changed type. If you then filter out a region, a step named filtered rows appears. If you replace a value, replaced value is added to the list. Why is this powerful? 1. It is a time machine. You can click on any previous step to see exactly what the data looked like at that moment in time. 2. It is editable. Did you filter for east but meant west? You don't have to undo everything. You can click the small gear icon next to the filtered rows step and change the logic. 3. It is automatable. Next month, when you get a new file with the same structure, Power BI runs these exact steps in this exact order. You do the work once, Power BI repeats it forever. Figure, detailed infographic style illustration of the applied steps pane. The steps are visualized as a vertical timeline or a stack of dominoes. The steps listed are source, promoted headers, changed type, removed columns, and filtered rows. An ethereal hand is hovering over the removed columns step, and an X icon, delete, and a gear icon, settings, are glowing next to it. This visualizes the ability to modify the middle of the process. Warning: the steps are sequential. If you delete a step early in the list, like changing a column name, and a later step relies on that name, you will break the query. Think of it like a Jenga tower, pull out the bottom blocks with caution. Summary: you have now successfully connected to your raw materials. You have stepped into the Power Query editor, turned on the lights with data profiling, and learned how to track your movements using applied steps. You are no longer just looking at a static spreadsheet. You are building a repeatable, robust data pipeline. The anxiety of breaking the file should be fading, replaced by the confidence that comes with non-destructive editing. In the next chapter, we will roll up our sleeves and start the actual cleaning process, transforming messy, human-generated data into a pristine dataset ready for analysis.
Chapter 2: The Cleanup, Transforming Messy Data into Usable Assets. Sections. Section 2.1: Essential Transformations, Trimming, Cleaning, and Changing Types. Section 2.2: Solving the Pivot Problem, Unpivoting Data for Analysis. Section 2.3: Merging versus Appending, Combining Tables the Right Way. Section 2.4: Creating Custom Columns with Conditional Logic. In Chapter 1, we built a pipeline to bring raw materials into our digital workshop. But let's be honest, raw data is rarely pristine. In my years as a data consultant, I have seen spreadsheets that would make a grown analyst cry, dates formatted as text, trailing spaces hiding in product names, and sales figures littered with typos. If you load that messy data directly into your dashboard, your calculations will break. Your charts will lie. As the old industry adage goes, garbage in, garbage out. This chapter is where we roll up our sleeves. We are entering the Power Query editor, the kitchen where the raw ingredients are chopped, peeled, and seasoned before cooking. If you are coming from Excel, think of this as a supercharged version of text to columns and standard formulas, but without the risk of accidentally deleting a cell. We are going to take the boring work of data cleaning and turn it into an automated, repeatable process. Once you fix a data issue here, you never have to fix it again. Figure, high-resolution, photorealistic workspace setup showing a monitor displaying the Power Query Editor interface. The screen highlights the applied steps pane on the right side with a glowing amber outline. On the desk, a messy stack of paper receipts transforms into a neat, organized digital stack on the screen, symbolizing the transition from chaos to order. Warm, professional office lighting. 2.1 Essential transformations: trimming, cleaning, and changing types. The moment you click Transform Data after selecting your source, a new window opens. This is Power Query. It exists separately from the main Power BI interface. The most important feature here is the Applied Steps pane on the right side of the screen. Every action you take, deleting a row, capitalizing a word, changing a decimal, is recorded here as a step. When you refresh your data next month, Power BI replays these steps automatically. You are not just cleaning data, you are programming a cleaning robot. The holy trinity of cleaning. There are 3 common issues that plague almost every dataset. We tackle these first to establish a baseline of quality. Trimming white space: human data entry is imperfect. A user might type apple with a space at the end instead of apple. To a computer, these are 2 different products. To fix this, right-click the column header, select Transform, and choose Trim. This strips invisible spaces from the start and end of your text. Cleaning control characters: sometimes data exported from legacy systems includes unprintable characters, like line breaks or tabs, that break your visuals. Right-click the header, select Transform, and choose Clean. It's a subtle fix that prevents major headaches later. Changing data types: this is non-negotiable. Each column must have a defined identity, text, whole number, date, or currency. If a column of numbers is formatted as text, you cannot sum them up. Look at the icon next to the column header. If you see ABC, it's text. If you see 123, it's a number. Click that icon to switch types. Figure, detailed UI mockup of the Power Query column header menu. A cursor hovers over the ABC icon next to a column named Sales_Amount. A drop-down menu is open showing options like decimal number, fixed decimal number, date, time, and a text. The decimal number option is highlighted in Power BI yellow. The background is blurred to focus on the menu. Why data types fail? Occasionally, you will try to change a text column to a number, and Power BI will return an error. This usually means there is non-numeric text hiding in the rows, like not applicable or dash. In Excel, you might hunt these down manually. In Power BI, we can handle them gracefully. By right-clicking the column and selecting Replace Errors, you can tell Power BI to swap those errors for a 0 or a null value, keeping the rest of your pipeline flowing. 2.2 Solving the pivot problem: unpivoting data for analysis. This section addresses the biggest mental shift for Excel users. In Excel, we build tables for human eyes. We put months across the top, January, February, March, and categories down the side. This is a pivoted all-wide format. It reads easily, but it analyzes poorly. Power BI prefers tall and narrow data. It doesn't want 12 columns for 12 months, it wants 1 column for the month and 1 column for the value. If you import a wide budget spreadsheet, you will struggle to write formulas that compare January to February. You need to unpivot the data. The unpivot workflow. Let's say you have a table with columns: product, Jan sales, February sales, and March sales. Select the column that acts as the anchor, in this case, product. Navigate to the Transform tab on the ribbon. Click the drop-down next to Unpivot Columns and select Unpivot Other Columns. Suddenly, your wide table collapses. You now have 3 columns: product, attribute, which contains the month names, and value, the sales numbers. Rename attribute to month and value to sales amount. You have just transformed a human-readable report into a machine-readable dataset ready for analysis. // this is what the M code looks like behind the scenes. Table.unpivot other columns, hashed change type, product, attribute, value. Do not worry about memorizing the code above, just understand that with 2 clicks, you solved a problem that would take complex VBA macros to fix in Excel. Figure, split screen comparison diagram. Left side shows a wider table labeled Excel format with months horizontally across headers, Jan, February, Mar. Right side shows a taller table labeled Power BI optimized where months are stacked vertically in a single column. An arrow labeled Unpivot Transformation connects the two, visualized as a mechanical funnel compressing the data. 2.3 Merging versus appending, combining tables the right way. Data rarely lives in a single file. You might have sales data in one CSV and product details in another. Or perhaps you have 12 separate Excel files, one for each month of the year. Power Query offers 2 primary ways to combine this data, merge and append. Confusing them is easy, but the distinction is simple if you visualize the geometry of your tables. Appending, stacking tool. Think of appending as stacking pages in a book. You have sales_January.xlsx and sales_February.xlsx. They have the exact same column headers. You want to place February underneath January to create a longer list. Go to the Home tab. Click Append Queries. Select the tables you want to stack. The result is one master table containing all historical data. This is crucial for analyzing trends over time. Merging, joining wide. Think of merging as the Power BI equivalent of lookup or XLOOKUP. You have a sales table with a product ID, but you need the product name which lives in a separate product catalog table. You want to add columns to the side of your existing table. Click Merge Queries. Select the common column in both tables, e.g., product ID. Choose your join kind. The default is left outer, which keeps all rows from your first table and matches what it can from the second. Once merged, you will see a column of table objects. Click the expand arrows, 2 small diverging arrows, in the header to select which columns you want to bring in, such as product name or category. Figure, conceptual isometric illustration. Top half shows appending, 2 blocks of data, blue and orange, being stacked vertically on top of each other to make a tall tower. Bottom half shows a merging, 2 blocks of data, blue and green, snapping together side by side like puzzle pieces to create a wider block. Labels are clear and bold. 2 point for creating custom columns with conditional logic. Sometimes the data you need doesn't exist in the source, you have to create it. Perhaps you need to group sales into high, medium, and low, or flag orders that were shipped late. In Excel, you would write an if statement, equals if, A2 100, high, low. In Power Query, we can do this without writing code using the Conditional Column tool. The Add Conditional Column interface. Navigate to the Add Column tab and select Conditional Column. A dialog box appears that allows you to build logic using simple drop-down menus. Scenario: we want to categorize orders based on the sales amount. Column name, order size. If sales amount is greater than or equal to 500, then large. Else if sales amount is greater than or equal to 100, then a medium. Else small. Power Query writes the logic for you. This creates a hard-coded text column in your dataset. Why do this in Power Query? You might wonder, can't I do this with a DAX formula later? Yes, you can. However, doing it here in Power Query is generally better for performance. Transformations done in Power Query are calculated once when the data loads. DAX calculated columns are recalculated constantly as you interact with the report. Whenever possible, push the heavy lifting of logic upstream to Power Query. / the logic Power Query writes for you. If sales amount greater than or equal to 500, then large. Else if sales amount greater than or equal to 100, then a medium. Else small. By adding this column now, you make the analysis phase significantly easier. You can simply drag order size onto a chart axis later without needing to write complex formulas on the fly. A clean slate. We have trimmed the fat, unpivoted the messy layouts, merged our reference tables, and added business logic. What was once a disjointed set of files is now a cohesive, structured data model. Take a moment to look at your applied steps pane. It might have 10 or 20 steps now. That is a workflow you used to do manually every Monday morning. Now, it happens instantly. With our data clean and structured, we are ready to move out of the kitchen and into the design studio. In the next chapter, we will discuss data modeling, where we define the relationships that allow these different tables to talk to each other.
Chapter 3, The Blueprint, Building a Relational Data Model. Sections. Section 3.1, Thinking in Relationships, Fact Tables versus Dimension Tables. Section 3.2, Connecting the Dots, Establishing Primary and Foreign Keys. Section 3.3, Understanding Cardinality, One-to-one, One-to-many, and Many-to-many. Section 3.4, The Star Schema, Why it is the gold standard for performance. In Chapter 2, we spent time in the kitchen of Power Query, scrubbing and prepping our raw ingredients. Now, we move to the drafting table. If data analysis were home construction, Power Query is where we pour the foundation, but the data model is where we frame the house. Many new Power BI users attempt to skip this step. They rush to drag fields onto a canvas, hoping for insights to magically appear. But without a proper model, your calculations will likely fail, and your performance will suffer. Data modeling is the process of defining relationships between your tables. It shifts us away from the flat, two-dimensional world of Excel spreadsheets and into a three-dimensional relational environment. This chapter is the blueprint for that structure. We are going to build a system where tables talk to one another efficiently, ensuring your reports are accurate, fast, and scalable. 3.1 Thinking in Relationships, Fact Tables versus Dimension Tables. The biggest mental shift for Excel users comes here. We are no longer building one giant master spreadsheet. In Power BI, we split our data into two specific types of tables, fact tables and dimension tables. Understanding the difference is critical because they serve entirely different purposes in your story. Fact tables contain the numbers. They record events or transactions. Think of these as the verbs of your data. A fact table answers the question, what happened? It contains values like sales amount, quantity sold, or transaction time. These tables are usually very long, millions of rows, but relatively narrow. Dimension tables contain the context. They describe the who, what, where, and when. Think of these as the nouns. A dimension table holds descriptive attributes like customer name, product category, or store location. These tables are usually wide, many columns of details, but short, fewer rows. Figure, a clean, high-contrast schematic diagram comparing a fact table and a dimension table. On the left, a dimension table labeled products shows columns for product ID, name, color, and category. It is short and wide. On the right, a fact table labeled sales shows columns for order ID, date, product ID, and amount. It is tall and narrow, implying infinite vertical scrolling. An arrow connects the product ID columns. The style is modern, minimal flat design with blue and gray tones. Why separate them? Efficiency and clarity. If you repeat the customer's full address on every single sales transaction row, you are bloating your model with redundant text. By separating them, we store the address once in the customer dimension and reference it only by an ID in the fact table. When you look at your tables, ask yourself a simple question to categorize them. Are these numbers I want to sum up, fact, or are these things I want to filter by, dimension? 3.2 Connecting the dots, establishing primary and foreign keys. Now that we have separated our data into facts and dimensions, we need a way to link them back together. We do this using keys. A relationship in Power BI works like a lookup, and it relies on a common column shared between two tables. A primary key is a unique identifier in a dimension table. Think of your employee ID or a social security number. In the products table, dimension, the product underscore ID must be unique for every row. There cannot be two products with the same ID, or the model won't know which one you are talking about. A foreign key is that same identifier appearing in the fact table. In the sales table, fact, the product underscore ID will appear many times, once for every time that product was sold. It is foreign because it points back to the home location in the dimension table. To create a relationship in Power BI, you simply drag the primary key from your dimension table and drop it onto the foreign key in your fact table. Figure, a close-up UI mockup of the Power BI model view. It shows two table cards, dim underscore customers and fact underscore sales. A mouse cursor is dragging a line from customer ID in the left table to customer ID in the right table. Highlighted tooltips show primary key, unique, on the left and foreign key, many, on the right. The background is a dark UI theme common in data tools. Once this line is drawn, the magic happens. When you use a filter from the dimension table, e.g., show me red bicycles, Power BI flows that filter down the relationship line to the fact table, keeping only the sales rows that match that ID. 3.3 Understanding cardinality, one-to-one, one-to-many, and many-to-many. When you drag that line between tables, Power BI will automatically assign a cardinality to the relationship. This describes the nature of the link between the data points. While there are a few types, 95% of the time, you are aiming for one specific setup. The one-to-many relationship, 1*. This is the standard. It means one row in the dimension table, one specific product, relates to many rows in the fact table, many sales transactions. In the model view, you will see the number 1 on the dimension side and an star on the fact side. This is what you want. It is stable, predictable, and fast. The one-to-one relationship, 1:1. This occurs when both tables contain unique values for the key column. For example, if you have a customer table and a customer demographics table, and both list each customer exactly once. While this works, it usually suggests that you should just merge these two tables into one larger dimension table back in Power Query to simplify your model. The many-to-many relationship, smiley face. This is the danger zone. It happens when neither column is unique. Beginners often stumble here when trying to link two fact tables directly, e.g., connecting sales directly to budget. Power BI allows this, but it introduces ambiguity. Filters can behave unpredictably, and totals may not calculate as you expect. Pro tip: if you encounter a many-to-many relationship, pause. It usually means you are missing a common dimension table, like a shared date or region table, to bridge the gap between the two fact tables. 3.4 The star schema, why it is the gold standard for performance. If you zoom out and look at a well-built data model, it shouldn't look like a bowl of spaghetti. It should look like a constellation. This layout is famously called the star schema. In a star schema, your fact table sits in the center. Your dimension tables radiate outward, surrounding the fact table like points on a star. The dimensions are not connected to each other, they are only connected to the central fact table. Why is this the gold standard? 1. Speed. The Power BI engine is optimized specifically for this shape. It can filter data incredibly fast when it only has to traverse one relationship to get from a filter to a number. 2. Simplicity. Writing DAX formulas, which we cover in Chapter 4, becomes much easier. You don't have to worry about complex logic to jump across multiple tables. 3. Usability. It makes sense to the human brain. You pick a filter from the star points, dimensions, and you see the result in the center, facts. Figure, a wide-angle 3D conceptual illustration of a star schema. The central block is a glowing golden cylinder labeled fact table. Surrounding it in a circular orbit are 5 silver cubes labeled dimensions, customers, product, date, store, region. Beams of light connect each silver cube directly to the central golden cylinder. The background is a deep tech blue, emphasizing the clean, organized structure. Avoid the snowflake schema if you can. A snowflake is when dimensions link to other dimensions, e.g., product links to subcategory, which links to category. While sometimes necessary, chains of relationships can slow down performance. Flatten your snowflakes into single, robust dimension tables whenever possible. By adhering to the star schema, you are ensuring your dashboard is robust. You are building a skyscraper on bedrock rather than sand. With your relationships set and your schema organized, you are now ready to begin the actual analysis.
Chapter 4, Speaking the Language, Introduction to DAX. Sections. Section 4.1, Calculated Columns versus Measures, Knowing which to choose. Section 4.2, Writing your first measure, Syntax, Operators, and Comments. Section 4.3, The Power of Context, Row Context versus Filter Context Explained. Section 4.4, Base Aggregations, Mastering SUM, Average, and Contros. In Chapter 3, we framed the house. We built a robust data model with solid relationships, moving away from flat files into a relational world. Now, it is time to turn on the electricity. If the data model is the engine of Power BI, DAX, data analysis expressions, is the fuel. For many Excel users, this is the moment of hesitation. You look at the formula bar, and it looks vaguely familiar but intimidatingly different. I remember my first week with DAX, I tried to write a standard Excel formula, hit enter, and was greeted by a screen full of red error text. It felt like I had traveled to a foreign country where I recognized the alphabet but didn't speak the language. Here is the good news, you already know the logic. You know how to sum a column, how to average sales, and how to use logic statements like if then. DAX is simply a new syntax for those old concepts, designed specifically to handle millions of rows of data instantaneously. In this chapter, we will break the language down. We won't just memorize formulas, we will learn how DAX thinks. Once you understand the mindset, the syntax becomes easy. For point 1, Calculated Columns versus Measures, Knowing which to choose. Before we write a single line of code, we must make a fundamental distinction. In Excel, every cell is a calculator. In Power BI, we have two primary ways to create new data, calculated columns and measures. Confusing these two is the number one mistake I see in beginner dashboards. Calculated columns, the static extension. A calculated column is exactly what it sounds like. You add a new column to your table, and Power BI calculates a value for every single row, immediately. Think of this like a permanent tattoo on your data. The result is calculated once, upon data refresh, stored in the file, and consumes memory, RAM. When to use a calculated column, * you need to slice or filter your data by the result, e.g., creating a short month name from a date. * you need to categorize data, e.g., high-ticket versus low-ticket transaction. Measures, the dynamic calculation. A measure is a virtual calculation. It does not exist on the table. It does not store data in RAM. It sits silently, waiting for you to drag it onto a visual. When you drop a measure into a chart, it calculates on the fly based on the current context, the filters you have applied. It is dynamic, lightweight, and incredibly fast. When to use a measure, * you want to calculate numerical aggregations, sums, averages, ratios, percentages. * the result changes depending on how you look at the report, e.g., total sales by year versus total sales by region. Figure, AI-ready prompt for diagram showing a split-screen comparison. Left side labeled Calculated Column, a database table icon with a new column being physically stamped onto it, looking heavy and permanent. Right side labeled Measure, a glowing, ethereal calculator icon floating above a chart, beaming numbers down dynamically. Visual style, clean, flat vector art, corporate tech blue and orange color palette. The golden rule, if you want to place the result on an axis, rows, columns, legend, use a calculated column. If you want to place the result in the values area, the bars in a bar chart, use a measure. For point 2, writing your first measure, syntax, operators, and comments. Let's write your first piece of DAX. We are going to calculate total sales. In Excel, you would scroll to the bottom of column C and type equals sum, C2, C5000. In Power BI, we don't reference cells, we reference tables and columns. Here is the anatomy of a measure. Total sales equals sum, sales, sales amount. Let's break that down. 1. Total sales, this is the name of your measure. Make it descriptive and readable. 2. Equals, the operator that starts the definition. 3. Sum, the function. It tells the engine what math to perform. 4. Sales, sales amount, the argument. This follows the format table, column. We are telling Power BI to go to the sales table and sum up that sales amount column. Operators. DAX uses standard mathematical operators that you are already comfortable with, asterisk plus, addition, asterisk, subtraction, asterisk asterisk, multiplication, asterisk, division. It also uses logical operators, asterisk and condition, asterisk, or condition, asterisk in, checks if a value exists in a list. The importance of comments. Code is read more often than it is written. 6 months from now, when you open this report to update it, you might forget why you added a specific filter. You can add comments to your DAX by using // for a single line. Power BI ignores anything after the double slash. Total revenue, net, equals sum, sales, sales amount, sum, sales, returns, // subtract returns to get net revenue. Writing clean code with comments isn't just nice to have, it is professional courtesy to your future self. For point 3, the power of context, row context versus filter context explained. This section is the most critical part of the entire book. If you understand context, you master DAX. If you ignore it, you will spend your career fighting against your own numbers. DAX results change depending on where they are displayed. The number of total sales might be $1 million in a card visual, but if you drag it into a table with year, it splits into $500,000 for 2023 and $500,000 for 2024. Why? Because of context. Row context, the iteration. Row context is the concept of current line. It is primarily used in calculated columns. Imagine you are reading a spreadsheet line by line with your finger. You look at row 1, quantity is 2, price is 10. You multiply them to get 20. Then you move your finger to row 2. Power BI does this automatically when you create a calculated column. It knows that for this row, it should only look at the data in this row. Filter context, the slicing. Filter context is what makes Power BI magical, and sometimes confusing. Filter context is the set of filters applied to the data model at the moment the calculation happens. These filters come from 1. Slices on the page, e.g., you selected USA. 2. Visual coordinates, e.g., a bar chart showing 2024 applies a filter for that year. 3. The filter pane on the side of the screen. Figure, AI-ready prompt for conceptual illustration showing filter context. A spotlight shines through several layers of glass filters. The top filter is labeled year equals 2024, the middle filter a region equals north. The light passes through and illuminates a small pile of data blocks at the bottom, representing the result. Lighting should be dramatic, emphasizing how filters reduce the data to a specific subset. The flashlight analogy, imagine your data is a massive dark warehouse filled with boxes, rows of data. *A measure is a command to count the boxes. *filter context is a flashlight. If you point the flashlight at the blue boxes section, the measure counts only blue boxes. If you widen the beam to the whole room, it counts everything. The formula, count the boxes, never changed. Only the area illuminated, the context, changed. For base aggregations, mastering SUM, average, and contros. Now that we understand the environment, let's look at the 3 tools you will use for 80% of your initial measures. Sum. The workhorse. It adds up all the values in a column, respecting the current filter context. Total quantity equals sum, sales, quantity. Author's note, sum requires a numeric column. You cannot sum text. If you try to sum product names, Power BI will yell at you. Average. This calculates the arithmetic mean. Average price equals average, sales, a unit price. Watch out for zeros. Average includes zeros in the calculation, but it ignores blank cells. If you have a day with $0 sales, it drags the average down. If you have a day where the store was closed, blank, it is excluded from the math. Ensure your data cleanup in Chapter 2 handled these correctly. Contros. In Excel, you probably use count or counter. In Power BI, the best way to count transactions is usually counting the rows of the table. Total transactions equals contros, sales. Notice a key difference here? Sum and average asked for a column, e.g., sales, quantity. Contros asks for a table, sales. It simply counts how many lines exist in the current filter context. If you have a slicer selected for red products, contros returns the number of transactions involving red products. It is simple, elegant, and incredibly powerful for volume analysis. Function input what it does. Moving forward. You have officially written your first code. You understand that measures are dynamic formulas that respond to user clicks, while calculated columns are static data stamps. You also learned that sum and contros are your bread and butter. However, sometimes standard math isn't enough. What if you want to calculate sales, but ignore the user selection? What if you want to compare this year's sales to last year's sales without rearranging your data? That requires bending the rules of context. In the next chapter, we will introduce the most important function in the DAX language, the function that allows you to rewrite reality.
Chapter 5, Leveling Up, Intermediate DAX and Time Intelligence. Sections. Section 5.1, The Calculate function, the Swiss Army knife of Power BI. Section 5.2, Handling dates, creating and marking a dedicated date table. Section 5.3, Time travel, comparing this year versus last year. Section 5.4, Running totals and year-to-date calculations. In Chapter 4, we turned the lights on. We learned basic DAX syntax and created our first measures to sum up sales and count transactions. It was a crucial step, but if we stop there, we are essentially using a Ferrari to drive to the mailbox. Power BI is capable of much more than simple aggregation. Real business insights rarely come from looking at a single number in isolation. Knowing that you sold $5 million this year is data. Knowing that this is a 20% increase over last year, despite a slow Q3, is intelligence. This chapter is where we bridge that gap. We are going to introduce the most important function in the DAX language, build the structural backbone of time analysis, and learn how to time travel through our data. If Chapter 4 was learning vocabulary, Chapter 5 is learning how to write poetry. 5.1 The Calculate function, the Swiss Army knife of Power BI. If you learn only one function in this entire book, make it calculate. In the Power BI community, we often say that you don't truly know DAX until you understand calculate. Why is it so special? In Excel, if you want to sum data based on specific criteria, you use SUMIF. In Power BI, calculate is SUMIF evolved into a superpower. It allows you to take an existing calculation and run it under a completely different set of rules, context, than what is currently selected on your report. How it works. Think of calculate as a yes, but, engine. Asterisk the report says, show me total sales. Asterisk calculate says, yes, I will show you total sales, but I am going to filter it to only show blue products. Here is the syntax. Calculate, expression, filter 1, filter 2. A practical example. Let's say we have a measure called total sales. We want to see sales specifically for our premium category, regardless of what other filters are applied. Premium sales equals calculate total sales product category equals premium. When you drag this new measure onto a card, it calculates the total sales measure, but before doing the math, it forces the data model to look only at rows where the category is premium. Figure, a split-screen diagram. On the left, a standard bar chart shows sales for all categories. On the right, a conceptual illustration of a funnel labeled Calculate filtering a stream of data blocks, allowing only premium blocks to pass through to the result. Clean, modern isometric style, soft blue and white lighting. Overriding filters. The true power of Calculate reveals itself when you start building ratios. Imagine you want to calculate the percent of total. To do this, you need two numbers. 1. The sales for the current selection, e.g., red bicycles. 2. The sales for everything, all bicycles. Calculate works beautifully with a function called all. The all function strips away filters. All sales equals calculate total sales all sales. Now, you can divide your specific sales by all sales to get a percentage that updates dynamically as you slice and dice your report. 5.2 Handling dates, creating and marking a dedicated date table. In Chapter 3, we discussed the star schema. Now, we need to introduce the most critical dimension table in that schema, the date table, often called a calendar table. Many beginners rely on Power BI's AutoDate time feature. This is where Power BI automatically creates hidden hierarchies, year, quarter, month, day, for every date column in your data. While convenient for quick sketches, it is terrible for professional models. It bloats your file size and prevents complex time intelligence calculations. To perform accurate time analysis, you must create a dedicated, continuous date table. Creating the table with DAX. We can generate this table programmatically. Go to the Modeling tab and select New Table. We will use the Calendar Auto function, which scans your entire model to find the earliest and latest dates, creating a contiguous list of dates between them. Dates equals Calendar Auto. Once you have this base column, you should add calculated columns for year, month, and quarter to make filtering easy. Year equals year, dates, date. Month num equals month, dates, date. Month name equals format, dates, date, MMMM. Marking as date table. This step is often skipped, leading to strange bugs later. You must explicitly tell Power BI that this is your official clock. Right-click your new dates table in the data pane. Select Mark as date table. Select the date column as the primary key. Figure, high-resolution screenshot of the Power BI desktop interface focusing on the Mark as date table dialog box. A bright orange highlight circle draws attention to the Validate Successfully checkmark. Professional UI style. Connecting the relationship. Finally, connect your dates, date, column to your sales, order date, column in the model view. Now, every time you want to slice by year or month, use the fields from your dates table, not the sales table. This ensures that if you had 0 sales on January 1st, January 1st still appears on your charts, because it exists in the date table. 5.4 Running totals and year-to-date calculations. Sometimes, stakeholders don't just want to see what happened in March, they want to see where we stand for the year up to March. This is a year-to-date, YTD, calculation. The easy way, total it. DAX provides sugar functions, shortcuts that make common patterns easy to write. Total it is one of them. Sales YTD equals total it. Total sales. Dates, date. This function automatically accumulates your sales starting from January 1st and resets on December 31st, unless you specify a different fiscal year end. Understanding the logic. Under the hood, total it is just calculate wearing a disguise. It tells Power BI, sum up the sales, but change the time filter to include all dates from the start of the year up to the current date in the visual. Visualizing accumulation. Running totals are best visualized using line charts or area charts. This allows the user to see the velocity of performance. If the line flattens out, you know accumulation has slowed, sales have dropped. If the line becomes steeper, performance is accelerating. Figure: a side-by-side comparison of two charts. Left: a standard column chart showing monthly sales, up and down. Right: an area chart showing the same data as a running total, always increasing. Arrows indicate how the monthly column adds to the previous total to build the area chart height. 5.3 Time travel. Comparing this year versus last year. Now that we have Calculate, section 5.1, and a Date table, section 5.2, we can combine them to perform time intelligence. This is the ability to shift the context of a calculation backward or forward in time. The most common request in business analytics is, how are we doing compared to last year? The SAMEPERIODLASTYEAR function. DAX makes this surprisingly easy. We don't need complex math, we just need to tell Calculate to look at the dates from exactly 1 year ago. Sales LY equals Calculate total sales. SAMEPERIODLASTYEAR dates, date. Note that we are referencing dates, date. This function requires a continuous date column, which is why the date table from the previous section is mandatory. Calculating variance. Once you have total sales, current, and sales LY, past, creating a variance measure is simple arithmetic. Sales YOY variance equals total sales, sales LY, and the percentage growth. Sales YOY % equals divide, sales YOY variance, sales LY, 0. Note: always use the divide function instead of the operator. Divide handles divide by 0 errors gracefully, preventing your report from crashing or showing infinity errors. Figure: a dual-axis line chart concept. The solid blue line represents current year sales, and a dashed gray line represents last year sales. Call-out boxes highlight the gap between the lines, labeled variance. The style is clean, corporate dashboard aesthetic. Chapter summary. We have moved from simple observation to deep analysis. By mastering Calculate, you now have the ability to manipulate the context of your data. By implementing a proper date table, you have ensured your time-based math is accurate and robust. And with time intelligence functions, you can now provide the historical context necessary for decision-making. In the next chapter, we will leave the formula bar behind and step onto the canvas. It is time to visualize these numbers and design a dashboard that is as beautiful as it is functional.
Chapter 6: Visualizing the story, choosing the right charts. Sections. Section 6.1: Visual hierarchy, matching data types to visual representations. Section 6.2: Beyond bar charts, using maps, cards, and KPI visuals effectively. Section 6.3: Controlling the narrative, filters, slicers, and the selection pane. Section 6.4: Drill down and hierarchies, allowing users to explore detail. In Chapter 5, we learned how to time travel with our data using advanced DAX. We built the logic that calculates year-over-year growth and cumulative totals. But right now, those brilliant calculations are likely sitting in a bland table or floating in the invisible memory of your computer. It is time to make them visible. If the data model is the engine and DAX is the fuel, then the visualizations are the dashboard of the car. It is the only part of your hard work that your end users will actually see. This chapter shifts our focus from calculation to communication. I have seen robust data models fail because the final report looked like a fruit salad of clashing colors and confusing pie charts. Conversely, I have seen simple models drive massive business decisions because the visuals were clear, intuitive, and told a compelling story. We are going to move beyond simply clicking icons in the visualizations pane. We are going to discuss the psychology of design, how to choose the perfect chart for your message, and how to give your users the power to explore the data themselves. Section 6.1 Visual Hierarchy, Matching Data Types to Visual Representations. Human beings are visual creatures. Our brains process images 60,000 times faster than text. When a stakeholder opens your Power BI report, they should know within 5 seconds what the data is saying, without having to read a single number. This is achieved through visual hierarchy. This concept dictates that the most important information should be the most prominent, grabbing the eye first. To achieve this, you must match your data type to the correct visual representation. Many beginners fall into the trap of variety for variety's sake. They use a donut chart because they already have 2-bar charts. Resist this urge. Consistency is better than novelty. Categorical data versus time series. The first question you must ask yourself is, am I comparing things, or am I showing a trend over time? If you are comparing categories, like sales by region or defects by product, bar charts are your best friend. Our eyes are excellent at comparing the lengths of bars. Horizontal bars are generally preferred for categorical data because they provide ample room for category labels, like long product names, on the y-axis. If you are showing data over time, like revenue by month, use a line chart or an area chart. Time almost always belongs on the x-axis, flowing from left to right. A line connects the dots, implying continuity and trend, which is exactly how we perceive the passage of time. Figure, a clean, minimalist infographic comparing 2 charts side by side. On the left, a horizontal bar chart labeled Categorical Comparison showing distinct blue bars with clear labels. On the right, a line chart labeled Time Series Trend showing a fluid upward trend line. The background is white, professional business style, with annotations pointing out easy label reading on the bar chart and trend continuity on the line chart. The part-to-whole dilemma. Now, let's address the elephant in the room, the pie chart. In the data visualization community, pie charts are controversial. Why? Because the human eye struggles to compare angles and area. It is very hard to tell if a slice represents 25% or 28% just by looking at it. However, they have a specific use case. If you have 2 or 3 categories, like in stock versus out of stock, a pie or donut chart works well. It gives a quick sense of proportion. But if you have 10 product categories, a pie chart becomes a cluttered mess that requires a color legend to decipher. In that scenario, always revert to a bar chart. Data Goal Recommended Visual Why? Section 6.2 Beyond Bar Charts, Using Maps, Cards, and KPI Visuals Effectively. While charts are great for patterns, sometimes a manager just wants to know, did we hit the target? For this, we need high-level summary visuals. In dashboard design, we often use the BAN method, big angry numbers, though hopefully, they are happy numbers. Cards and multi-row cards. The card visual is the simplest element in Power BI. It displays a single number. Use these at the very top of your dashboard to display your headline metrics, total revenue, total orders, or current year sales. I recommend grouping 3 to 5 cards at the top of your report canvas. This anchors the user. Before they dive into the breakdown by region or product, they understand the global context of the data. To use a card, 1. Select the card icon, the one with the 123 symbol. 2. Drag your key measure, e.g., total sales, into the fields well. 3. Use the format pane to remove the background and adjust the font size to align with your design theme. The KPI visual. A number in isolation can be dangerous. If I tell you we sold $1 million, is that good? If the target was $500,000, it's amazing. If the target was $2 million, it's a disaster. The KPI, Key Performance Indicator, visual adds this context. It requires 3 inputs. 1. Value, what is happening right now? E.g., current month sales. 2. Trend axis, what is the time period? E.g., month. 3. Target, what is the goal? E.g., monthly budget. When configured correctly, the KPI visual changes color, green for good, red for bad, and displays the variants automatically. This creates an immediate emotional connection to the data. The user feels relief or concern instantly. Figure, close-up of a Power BI dashboard header. 3 distinct visuals are aligned horizontally. Left, a standard card visual showing the $1.2M. Center, a multi-row card showing distinct category totals. Right, a KPI visual with a green trend line and green text indicating plus 15% versus target. The style is modern, sleek, with soft drop shadows. Maps, use with caution. Power BI integrates beautifully with Bing Maps. It is tempting to throw a map onto every dashboard because they look impressive. However, maps are often space expensive. They take up a lot of room for very little data density. Use maps only when geography is the primary driver of the story. If you need to see exactly where deliveries are delayed, a map is perfect. If you just want to compare sales by state, a bar chart is actually faster to read and takes up less space. Section 6.3, Controlling the narrative, filters, slicers, and the selection pane. Static reports are for printers. Power BI reports are alive. The true power of this tool lies in interactivity. You want to invite your user to have a conversation with the data. Slicers, the user's remote control. A slicer is an on-canvas visual that filters all other visuals on the page. By placing slicers for year, region, or product category on your canvas, you empower the user to answer their own questions. Instead of emailing you to ask, "What did the East region do in 2023?" they simply click East and 2023 on your slicers. Pro tip, change the orientation of your slicers. By default, they are vertical lists. In the Format pane, under Slicer Settings Options Orientation, you can switch them to horizontal or tile in newer versions. This turns them into clickable buttons that look like a sophisticated app navigation bar. The Selection pane, Layer Management. As you add background shapes, text boxes, charts, and buttons, your canvas can get crowded. Sometimes, you might try to click a chart, but you accidentally select the background rectangle behind it. Enter the Selection pane. You can find this in the View tab on the ribbon. Think of the Selection pane like the Layer panel in Photoshop. It lists every single object on your page. From here, you can 1. Rename objects. Instead of Shape 1 and Card 5, rename them to Header Background and Total Sales Card. 2. Reorder layers. Drag items up or down to decide what sits on top of what. 3. Hide objects. Click the eye icon to temporarily hide visuals while you work on the layout. This is critical for accessibility and screen readers, but it also keeps your sanity intact when designing complex dashboards. Figure, a screenshot simulation of the Power BI desktop interface focusing on the View tab. An arrow points to the Selection button. On the right side, the Selection pane is expanded, showing a list of named layers like Header Background, Slicer Panel, and Sales Chart. The eye icon is visible next to each layer. The visual implies organization and structure. Section 6.4, Drill Down and Hierarchies, allowing users to explore detail. One of the biggest mistakes beginners make is trying to cram every single detail onto one page. They create a table with 5,000 rows because they are afraid the user will miss something. This leads to cognitive overload. Instead, follow the Schneiderman mantra of data visualization: overview first, zoom and filter, then details on demand. We achieve this in Power BI using hierarchies and drill down. Creating a hierarchy. In Chapter 3, we built a calendar table. That table contains year, quarter, month, and date. We can group these fields into a hierarchy. Go to the Data view or Model view. Right-click your Year column and select Create Hierarchy. Drag quarter, month, and date into that new hierarchy in the Fields pane. Now, when you drag this hierarchy into a bar chart, you don't just get a static view. You enable the drill-down buttons. The drill-down experience. When a hierarchy is present in a visual, a set of arrow icons appears in the header of that visual, usually top right or top left. The down arrow, drill mode. When clicked, this turns your mouse into a drill. If you click on the 2024 bar, the chart updates to show you the quarter specifically for 2024. The double down arrow, go to next level. This ignores the parent context and just aggregates the next level. It would show you Q1, Q2, Q3, and Q for totals for all years combined. The pitchfork, expand all down one level. This is usually the most useful. It expands the view to shows 2024 Q1, 2024 Q2, etc. It preserves the parent context while showing the child detail. By teaching your users how to use these buttons, perhaps with a helpful tooltip, you can keep your report clean. Show them the yearly trend first. If they see a spike, let them drill down to find the month, and then the specific day, where the anomaly occurred. This approach transforms your report from a static picture into an investigative tool. You are not just presenting data, you are providing a guided path to insight.
Chapter 7, Design for Impact, Formatting and User Experience. Sections. Section 7.1, The Z Pattern, Structuring Your Dashboard for Readability. Section 7.2, Color Theory and Accessibility, Designing for All Eyes. Section 7.3, Dynamic Interactivity, Using Bookmarks and Buttons. Section 7.4, Tooltips and Hover Effects, Adding Context Without Clutter. In Chapter 6, we focused on selecting the right visuals to tell a story. We moved from raw numbers to bar charts and line graphs, giving our data a voice. But having the right charts is only half the battle. If those charts are cluttered, misaligned, or difficult to navigate, your message will get lost in the noise. There is a distinct difference between a report that works and a report that people love to use. That difference lies in user experience, UX. I have seen technically brilliant dashboards, backed by complex DAX and perfect data models, fail because they looked like a control panel from a 1980s sci-fi movie. They were overwhelming. In this chapter, we are going to polish our work. We will transform your report from a static collection of charts into an interactive, app-like experience that guides the user's eye and answers their questions intuitively. Section 7.1, The Z Pattern, Structuring Your Dashboard for Readability. When a user opens your dashboard, they do not read it like a book. They scan it. Eye tracking studies have consistently shown that in Western cultures, business users process a screen in a specific Z pattern. They start at the top left, scan across the top right, cut diagonally through the center, and finish at the bottom right. Understanding this behavior allows us to place our insights strategically rather than randomly. Figure, a clean, schematic wireframe diagram of a dashboard layout. Overlaid on the wireframe is a bold, semi-transparent arrow tracing a Z shape. The top left corner is labeled Primary KPIs Headline, the top right is labeled Global Filters, the center diagonal area is labeled Trends and Breakdowns, and the bottom right is labeled Detailed Data Exports. The style should be minimal and instructional, utilizing blue and gray tones. The top left corner, Prime Real Estate. The top left corner is the most valuable real estate on your screen. This is where your most critical numbers, your headline KPIs, must live. If you are building a sales dashboard, this is where total revenue and year-over-year growth belong. Do not waste this space on a company logo or a massive title. Place those in the header, but keep the data front and center where the eye naturally lands first. The top right, User Control. As the eye moves across to the right, the user is looking for context or control. This is the ideal location for your slices, date, region, category. By placing filters here, you establish a contract with the user. Here are the numbers, left, and here is how you change them, right. It creates a natural flow of interaction that feels familiar to anyone who has used a modern website. The center and bottom, the story. The diagonal slice through the middle is where your supporting visuals go. This is the place for your trend lines and categorical bar charts. Finally, the bottom of the screen is for the granular details, perhaps a table of specific transactions. By following this hierarchy, You reduce the cognitive load on your audience. They don't have to hunt for the answer, the layout hands it to them. Section 7.2, Color Theory and Accessibility, Designing for All Eyes. Novice designers often treat color as decoration. They pick colors because they look nice or match the company logo. However, in data visualization, color is a data point. It represents meaning. If you use green for a bar chart on sales and green for a bar chart on customer count, you are implicitly telling the user these two things are related. If they aren't, you create confusion. The rule of consistency. Stick to a limited color palette. A good rule of thumb is the 60-30-10 rule used in interior design. Use a neutral color, like gray or soft blue, for 60% of your data, a secondary color for 30%, and a bold accent color for the remaining 10% to highlight specific insights. Avoid the fruit salad effect where every bar in a chart is a different color. If the categories are labeled on the axis, you do not need a legend or varying colors. It adds visual clutter without adding information. Designing for accessibility. Figure, a side-by-side comparison image. The left side shows a bad example, a bar chart where every bar is a different bright neon color, red, green, blue, yellow, purple, with a messy legend. The right side shows a good example, the same bar chart using a sleek monochromatic blue palette, where only the highest value bar is highlighted in a contrasting dark blue color. The background is white clean, emphasizing professional design. We must also design for inclusivity. Approximately 1 in 12 men and 1 in 200 women have some form of color blindness, color vision deficiency. The most common issue is distinguishing between red and green. If your dashboard relies solely on red for bad and green for good, a significant portion of your audience might see them as the same muddy brown. To fix this, combine color with icons or position. Or, use a colorblind safe palette. A popular alternative is using blue for good and orange-red for bad, as these provide better contrast. Power BI allows you to customize your theme via the View tab. Go to the View ribbon. Click the drop-down arrow on the Themes gallery. Select Customize Current Theme. Under Name and Colors, you can input specific hex codes to ensure high contrast. Section 7.3, Dynamic Interactivity, Using Bookmarks and Buttons. This is the section where we turn your report into an application. Have you ever wanted to toggle between a chart and a table without leaving the page? Or create a Reset All Filters button? We achieve this using 3 features working in harmony: the selection pane, the bookmarks pane, and buttons. The selection pane, managing layers. Think of the selection pane as the layer manager in Photoshop or PowerPoint. It allows you to hide or show specific visuals. To open it, go to the View tab and check Selection. You will see a list of every object on your page. You can click the eye icon next to any visual to make it invisible. This is the mechanism we will manipulate. Bookmarks, saving a state. A bookmark saves the current state of your report, including which visuals are hidden, which are visible, and what filters are applied. Let's create a Reset Slices bookmark. 1. Clear all your slices so the dashboard shows all data. 2. Open the Bookmarks pane, View Bookmarks. 3. Click Add. Rename it Reset. 4. Crucial step, right-click the bookmark and uncheck Data. *Y. If data is checked, the bookmark remembers exactly which data points were highlighted. We usually only want it to remember the filter context, the slices. For a reset button, we actually want it to remember the empty slicer state, so keep data checked only if you want to force specific filters. Buttons, the trigger. Now, we need a button to activate the bookmark. 1. Go to Insert Buttons Reset. 2. Place the button on your canvas, top right is standard. 3. With the button selected, go to the Format pane. 4. Turn on action. 5. Set the type to bookmark and select your reset bookmark. Now, when a user clicks that button, Ctrl+click in Desktop, Standard click in Service, the report snaps back to the state you saved. It creates a seamless, professional experience. Figure, a screenshot-style visualization of the Power BI interface focusing on the action settings for a button. On the canvas, a sleek button labeled Reset Filters is selected. On the right side, the format pane is zoomed in, highlighting the action toggle switched to on, the type set to bookmark, and the bookmark selected as Reset View. Highlighting lines indicate the connection between the button and the setting. Section 7.4, Tooltips and Hover Effects, adding context without clutter. One of the biggest mistakes beginners make is trying to cram every possible answer onto a single page. This leads to chart junk. The solution is progressive disclosure. Show the high-level summary first, and reveal the details only when the user asks for them. In Power BI, we do this with report page tooltips. Standard tooltips show the value of a bar when you hover over it. Report page tooltips allow you to embed an entire miniature report page inside that hover box. Creating a report page tooltip. Create a new page in your report. Go to Format your report page canvas settings. Change the type from 16:9 to Tooltip. The canvas will shrink to a small square. Build a small visual here. For example, if your main report shows sales by country, this tooltip page could show a top 5 products list for that country. Linking it to the main visual. Once your mini page is built, let's call it Tooltip Products 1. Go back to your main dashboard page. 2. Select your main chart, e.g., sales by country. 3. Go to the Format pane General Tooltips. 4. Change the type to Report Page. 5. Select Tooltip Products from the page drop-down. Now, when you hover over Germany on your main chart, a small window pops up showing the top products sold specifically in Germany. You have provided deep granular detail without taking up a single pixel of space on your main dashboard. This technique keeps your design clean and your users focused, while still providing the depth of data they need for analysis.
Chapter 8, the final Polish, Publishing and Sharing. Sections. Section 8.1, From Desktop to Cloud, Publishing to the Power BI Service. Section 8.2, Workspaces and Apps, Organizing Content for Teams. Section 8.3, Keeping Data Fresh, Configuring Gateways and Scheduled Refresh. Section 8.4, Mobile Optimization, Designing Layouts for Phones and Tablets. In Chapter 7, we focused on the user experience. We meticulously aligned our charts, chose the perfect color palette, and ensured that navigating the report felt intuitive. Your report now looks professional and tells a compelling story. But currently, that story is trapped. It lives on your hard drive as a local .pbix file. If you want to show it to your manager, you might be tempted to attach that massive file to an email or drop it in a shared folder. Please, resist that urge. Sending a raw Power BI file is like handing a restaurant customer the ingredients and a recipe card instead of a plated meal. We need to serve the finished product. This chapter covers the final, critical leg of our journey, distribution. We will move our work from Power BI Desktop to the Power BI Service, the cloud, ensure the data stays up to date automatically, and even optimize the experience for the CEO checking numbers on their smartphone between meetings. This is where your analysis transforms from a personal project into an organizational asset. 8.1 From Desktop to Cloud, Publishing to the Power BI Service. Up until this point, we have worked exclusively in Power BI Desktop. This is your creation studio. It is free, powerful, and offline. However, business value is realized in the Power BI Service, the secure cloud platform where users view and interact with your reports. The bridge between these two worlds is the Publish button. Located on the Home ribbon, this button initiates the handoff. When you click it, Power BI bundles your data model, your DAX measures, and your visual canvas, pushing them up to the Microsoft Cloud. The My Workspace trap. When you click Publish, you are asked to select a destination. By default, everyone has a My Workspace. It serves as your personal sandbox. For testing, My Workspace is fine. But for professional distribution, avoid it. If you leave the company or go on vacation, no one else can manage the content in your personal workspace. It becomes a silo. Instead, we want to publish to a standard workspace, a shared environment designed for collaboration. We will cover creating these in the next section, but for your very first publish, understanding this distinction is vital. Figure, a high-contrast, split-screen diagram. On the left, a laptop screen showing the Power BI desktop interface with a glowing cursor hovering over the Published button in the ribbon. On the right, a cloud icon representing the Power BI service. An arrow flows from the laptop to the cloud, carrying a file icon labeled .pbix. The style is modern tech vector art, blue and white color scheme, clean lines. The publishing process. Here is what happens when you publish. Authentication, you log in with your organizational account. Selection, you choose the destination workspace. Upload, Power BI uploads the file. Success, you receive a link to view the report in the browser. Once the report is in the service, the behavior changes. You can no longer edit the data model or write DAX, generally speaking. You are now in a consumption mode. Your users can filter, drill down, and export data, but they cannot break the underlying structure you built. 8.2 Workspaces and Apps, Organizing Content for Teams. If you have ever struggled to find a file in a messy shared network drive, you understand the importance of organization. In Power BI, we manage content using a two-tier hierarchy, workspaces and apps. Think of a workspace as the kitchen in a restaurant. It is where the chefs, you and your fellow analysts, work. It is messy. There are half-finished datasets, reports in testing, and version 1, 2, and 3 of the same dashboard. You do not want your customers, the business users, walking through the kitchen. You want them seated at the table. In this analogy, the app is the dining room. Configuring a workspace. A workspace is a collaborative folder. You grant access based on roles. Admin can delete the workspace and manage access. Member can publish reports and share content. Contributor can edit content but cannot publish the app. Viewer can only look. For a standard project, I usually create a workspace named something specific, like Sales Analytics Team. I add my fellow analysts as contributors so we can collaborate on the files. Publishing an app. Once your reports in the workspace are polished and ready for the wider audience, you create an app. An app bundles one or more reports from a workspace into a clean, navigational interface. It strips away the clutter of the Power BI interface and gives the user a sleek menu on the left side of the screen. When you share the app link, users see exactly what you want them to see. If you need to make changes later, you update the report in the workspace, the kitchen, but the users in the app, the dining room, won't see the changes until you hit Update App. This provides a safety buffer for development. Figure, a conceptual infographic comparing the workspace and the app. The left side shows a workspace represented as a busy, open-plan office or kitchen with gears, tools, and multiple file icons, labeled a collaboration and development. The right side shows an app represented as a neat, framed presentation on a tablet or monitor, labeled consumption and distribution. A one-way arrow points from workspace to app labeled a published. 8.3 Keeping data fresh, configuring gateways and scheduled refresh. A dashboard is only as good as its data. If your manager opens your beautiful sales report on Tuesday, but it still shows data from last Friday, trust evaporates instantly. In Power BI Desktop, you clicked refresh manually. In the service, we automate this. Cloud versus on-premises data. If your data lives in the cloud, e.g., SharePoint Online, Salesforce, Azure SQL, Power BI can usually reach it directly. You simply enter your credentials in the service, and it works. However, if your data sits on a local server, like an on-premise SQL database, or a mapped network drive, like an Excel file on the Z drive, the cloud cannot see it. The cloud is outside your company's firewall, your data is inside. To fix this, we need a bridge, the on-premises data gateway. The data gateway. The gateway is a piece of software installed on a computer within your network that stays on the 24th of July. It acts as a secure tunnel. When Power BI service requests data, the gateway opens a secure connection, grabs the data, and sends it up to the cloud. You generally do not need to install this on your personal laptop. In most organizations, IT will install the standard mode gateway on a server. Your job is to map your dataset to that gateway. Setting the schedule. Once the connection is established, you can set a scheduled refresh. Go to your workspace. Find the dataset, not the report, and click the settings icon. Expand scheduled refresh. Toggle it to on and select your times, e.g., 8 a.m. and 1 p.m. Now, you can sleep soundly knowing your report will greet your users with fresh numbers every morning. 8 point for mobile optimization, designing layouts for phones and tablets. I learned this lesson the hard way. I once built a dense, landscape-oriented dashboard for a CFO. It was packed with matrices and detailed charts. I sent him the link, proud of my work. He replied 10 minutes later, "I'm at the airport checking this on my iPhone. I can't read a thing. The charts are tiny." Executives live on their phones. If your report isn't mobile friendly, it isn't executive friendly. The mobile layout view. Fortunately, you do not need to build a separate report from scratch. Power BI Desktop has a dedicated mobile layout view. At the bottom of the view ribbon, click on the mobile layout icon. You will see a phone silhouette on a canvas. On the right, you will see a list of all the visuals currently on your page. This works like a drag-and-drop puzzle. You can drag visuals onto the phone frame and resize them to fit the vertical screen. Design principles for mobile. Designing for mobile requires a ruthless less is more approach. Stack vertically, phones scroll up and down. Stack your KPIs at the top, followed by 1 or 2 crucial charts. Remove clutter, you don't need every slicer and every detail table. Hide the elements that are too dense for a 6-inch screen. Finger-friendly, leave space. Buttons and slicers need to be large enough for a thumb tap. Any changes you make here only affect the mobile view. The desktop view remains untouched. When a user opens the report on the Power BI mobile app, the service automatically detects their device and serves up this optimized layout. Figure, a screenshot comparison of the mobile layout editor in Power BI. The center shows a smartphone outline with a grid. On the right, a pane labeled Visuals contains icons of charts. A cursor is dragging a KPI card from the pane onto the phone grid. The background is the dark gray Power BI desktop interface. Focus is on the ease of drag and drop. The journey so far. We have traveled a long road. We started with messy raw data, cleaned it in Power Query, modeled it into a relational star schema, calculated insights with DAX, visualized them with charts, and finally published a polished, automated app to the cloud. You now possess the end-to-end skills of a Power BI developer. You can take a business question and turn it into a deployed, automated solution. However, the learning curve doesn't end here. In the data world, the landscape is always shifting. In the final chapters, we will look at how to maintain this momentum and where to go next to deepen your expertise.
Conclusion: your journey as a data analyst. Sections. Section 9.1, a capstone review, from raw data to finished dashboard. Section 9.2, staying current, resources for continuous learning. Section 9.3, common pitfalls to avoid in your first year. Section 9.4, the road ahead, advanced certifications and career paths. We have reached the end of this specific project, but we are at the very beginning of your journey. Think back to when you first opened Power BI Desktop in Chapter 1. The interface likely felt cluttered, the concept of a data model seemed abstract, and DAX looked like a foreign language. You may have felt that familiar urge to just retreat to Excel, where VLOOKUPs and pivot tables feel safe and predictable. But you stayed. You pushed through the error messages, the broken relationships, and the blank visuals. Now, you possess a skill set that is in high demand. You are no longer just a spreadsheet user, you are a data storyteller. You have learned to take raw, messy chaos and transform it into clear, actionable intelligence. This concluding chapter is not about new technical buttons to click. It is about how to carry these skills forward, how to survive your first year as an official Power BI developer, and how to navigate the career path ahead. Figure: a clean, minimalistic vector illustration showing a winding path up a mountain. At the base, icons represent raw data, CSV, Excel. At the first plateau, a data model schematic. Higher up, a chart icon. At the summit, a glowing light bulb representing insight. The style should be flat design, professional blues and yellows, conveying progress and achievement. 9.1a Capstone Review: from raw data to finished dashboard. Before we look forward, let's solidify what we have built. Understanding the entire workflow holistically is what separates a novice from a professional. A novice creates charts, a professional builds pipelines. We can break down our journey into 4 distinct phases. If you ever get stuck in future projects, return to this framework to diagnose where the problem lies. Phase 1. Preparation, Power Query. We started in the kitchen. In Chapter 2 and 3, we used Power Query to clean our ingredients. We learned that shaping data, unpivoting columns, setting correct data types, and merging queries is 70% of the work. Remember, if your charts feel impossible to build, the problem is rarely the chart. The problem is usually that the data wasn't cleaned properly in this phase. Phase 2, Foundation, the data model. We then moved to the framing of the house. We established the star schema. We separated our descriptive data, dimensions, from our transactional numbers, facts. We learned that a one-to-many relationship is the heartbeat of Power BI. Without this structure, our reports would be slow, prone to errors, and difficult to update. Phase 3, Intelligence, DAX. In Chapters 4 and 5, we added the electrical wiring. We moved beyond simple sums and used DAX to ask complex questions. We calculated year-over-year growth and time-based comparisons. We learned that DAX is context-dependent. It changes based on the filters the user applies. This dynamic nature is what makes Power BI distinct from a static Excel report. Phase 4, Communication, Visualization and Publishing. Finally, in Chapters 6, 7, and 8, we focused on the user. We designed for clarity, removed clutter, and published our work to the service. We learned that a report is only successful if the end user can understand it without an explanation. Figure: an isometric diagram illustrating the Power BI lifecycle. Left side, a funnel labeled Power Query taking in various file icons. Center, a cube structure labeled Data Model with DAX sparks surrounding it. Right side, a computer screen displaying a dashboard labeled Power BI Service. Arrows connect them linearly from left to right. Lighting is soft and modern technical. 9.2 Staying current, resources for continuous learning. Here is the one thing I can guarantee about Power BI: by the time you read this, something has changed. Microsoft updates Power BI Desktop monthly. Sometimes these are small tweaks, other times, they are massive features that change how we work, like the introduction of calculation groups or field parameters. This rapid pace is exciting, but it can be overwhelming. You do not need to relearn the software every month, but you do need a strategy to stay informed. The update ritual. Make it a habit to check the official Microsoft Power BI blog once a month. They release a summary of all new features. Scan through it to see if anything solves a problem you have been facing. Community leaders. The Power BI community is exceptionally generous. There are a few pillars of the community that every analyst should follow. While I cannot list URLs that might break, search for these names. SQLBI, Marco Russo and Alberto Ferrari, they are the definitive authorities on DAX. If you want to understand why your code works, or doesn't, go to them. Guy in a Cube, Adam Saxton and Patrick LeBlanc. They provide short, high-energy videos on practical tips and updates. Perfect for quick learning. Enterprise DNA. Excellent resources for visualization techniques and design patterns. The help method. When you hit a wall and you will, knowing how to Google the problem is a skill in itself. Don't just search DAX error. Be specific. Power BI DAX calculate percentage of total specific year. Including DAX or Power Query in your search terms is vital, otherwise, you will get Excel formulas that won't work here. 9.3 Common pitfalls to avoid in your first year. As you step out into the real world to build reports for your boss or clients, you will face challenges that aren't technical, they are strategic. I have made many mistakes in my career. Here are 3 traps I fell into during my first year, so you can avoid them. The kitchen sink trap. When you first learn Power BI, you want to show off everything you can do. You might try to squeeze sales data, HR metrics, inventory levels, and marketing spend all into one massive .pbix file. The fix: keep your scope narrow. A report should answer a specific set of questions for a specific audience. It is better to have 3 small, fast reports than one massive report that takes 5 minutes to load. The Excel reversion. You will be tempted to build a matrix visual that looks exactly like the Excel spreadsheet your team used to use. It will have 50 columns and thousands of rows. The fix: push back gently. If users just want a giant grid of numbers, they should stay in Excel. Power BI is for finding patterns, trends, and outliers. Use charts to highlight the story, and offer a detail page for the raw numbers if absolutely necessary. Ignoring performance. It is easy to write DAX that works on 1,000 rows but crashes on 1 million rows. The fix: if a visual takes more than 3 seconds to load, it is too slow. Usually, this means you have bidirectional relationships in your model, Chapter 3, or overly complex iterators in your DAX. Always prioritize a clean star schema over complex formulas. Figure: a split-screen comparison illustration. On the left, labeled the pitfall, a chaotic dashboard with too many colors, a spinning loading icon, and a clutter of sticky notes. On the right, labeled the goal, a sleek, balanced dashboard with green checkmarks indicating speed and clarity. High contrast between the chaotic red tones on the left and calm blue tones on the right. 9.4 The road ahead, advanced certifications and career paths. Where do you go from here? For many, this book is just the spark that ignites a new career trajectory. Data is the new oil, but data analysts are the refinery. Companies are desperate for people who can refine that raw data into fuel for decision-making. The gold standard, PL 300. If you want to prove your skills to an employer, I highly recommend pursuing the Microsoft Certified Power BI Data Analyst Associate exam PL 300. This book has covered a significant portion of the material required for that exam. Certification validates that you understand the Microsoft way of doing things. It is a powerful resume booster that separates hobbyists from professionals. Expanding your toolkit. Power BI is rarely used in a vacuum. As you grow, consider adding these skills to your utility belt. SQL, Structured Query Language. Power BI gets data from databases. Knowing SQL allows you to extract exactly what you need before it even hits Power Query. Python or R, for advanced statistical analysis or custom visuals that go beyond standard charts. Power Automate, to trigger actions based on your data, e.g., sending an email when sales drop below a target. Final thoughts. You have done the hard work. You have learned the logic, the language, and the layout of modern analytics. Don't be afraid to experiment. Break your models. Write bad DAX, fix it, and learn why it failed. Open that blank canvas and start building. Your data has a story to tell. You are now the one equipped to tell it. Good luck, and happy analyzing.